most of you guys like to work in the dark anyway. It's one of the things I've noticed. When you're over working under the hood, you'll be in the dark. All right. Okay. All right, you got your manual 5-speed transaxle. There's your clutch disc. There's your pressure plate. There's the flywheel on the back of the motor.
Hey, what happened to the cop bringing in the truck?
I have not heard another word from him.
He had family issues. Grandpa put in ours.
All right. That's all right. There's your clutch release right there. And see that clutch release goes down through there and hooks to this. And this right here is your throw-out bearing. Now this is a older transaxle. It's fairly easy to understand the way this one operates if you actually we've already been through the other stuff. But there you go. There's these bolts right here, what you take off, and this is exactly the same transaxle that we got over there on the bench. I mean, that we were looking at the other day. And all right, let's go to our next page here. Oh, I just love it whenever that happens. We're all sideways, but that's all the parts. This is a sideways picture of it, but you can see all of this stuff. And I ought to be able to
rotate.
I'll be able to rotate that. I don't know if this version of, yeah, there it is, rotate view clockwise. There, now we can make that happen. See the case out, see the case. What's that right there? Somebody tell me what that is. What's that? Okay. Now man, what's this right here?
Speedometer.
That's a speedometer gear. That's where you're going to pull that out and check your oil. Right there, on that one. And this right here is part of your shifter. That right there, what is this part?
Differential.
And that gear right there?
Pinion gear.
Huh?
No, it's not a pinion. No.
That's the ring gear. That's the differential. Don't play dumb with me. All right. Now then, right here, and there's some more shift linkage here. And all you see on the myriad number of parts. How many parts is that? Can somebody count them? How many parts is it?
109. 108.
That's 122, right?
Yeah, 120.
122 parts. What are these gears right here?
That's
Huh?
your spider gears.
Spider gears. There you go. Why are those spider gears in there? Somebody tell me why the spider gears are there. Huh? Why are the spider gears? Huh? Why are the spider gears there?
So like.
So we can change direction.
No, it's so it'll allow one wheel to spin and one wheel won't. I don't know.
Whenever you turn, one of the wheels is having to go faster than the other one, and you got to keep transmitting torque during that time. The only problem with that is when you're taking off, it has a tendency to spin one of the wheels in the wet grass and the other one doesn't. That's what traction control, positive traction is all about. And that's all of the names for those. There's your shift mechanism for that transmission. See?
What kind of transmission is it?
That's out of an Escort, an old like 80. Older model Escort. Escorts are good. They're our friend.
No, they're not.
Yeah, we like them. So. And they,
well,
they usually, when you dial them up just right, they can outrun a Nissan in a week. So. I'm just kidding. All right, see, there's your shifter right there, and this is the boot. You know that boot sometimes, if it's too stiff and all, can cause it to, you can pull it out of gear. It don't usually happen, but it's kind of funny how that works. And then there's your little shift, all that stuff. Look at it. You know what's that for? What is that?
That's to put in gear.
Are you sure? That part right there?
Sure. Looks like a mountain bracket to me.
What is that? That's got wires, man.
I don't know how to see wires.
Huh? What is that? What in the world are we looking at there?
I see that part.
What is that? Why in the world would you have wires hooked to a manual transmission?
Oh, it's gear switch.
What about backup lights, man?
I don't got backup lights.
Come on. That's it. He's playing dumb again. All right, now then, there's your shift trail system right there. See all that shifter linkage? They're just giving you that. Neat little stuff there. Matter of fact, on one of your questions, I've got a picture of this right here. And I'll say, what is this? If I remember right, when I put that together. And we're going to be looking at power flow on this thing in a minute. Hang on. All right. Oh, look at here. Major functions and components. All right. A is the transmission section. See the little dotted box right there? Yeah. Between the clutch and the differential, you got 5 forward gear ratios and 1 reverse gear ratio. And the differential section is down here at the bottom. Now, some of y'all might have remembered, and this is actually an automatic transmission deal. That on the Toyota transmission, like the one we got on this 98 Camry out here, that section of that transmission is swimming in a different oil than all the rest of it. I told you this before.
Hey, how they do that?
Actually, because of the fact that it needs they didn't want this swimming in automatic transmission fluid. They wanted it in gear oil.
How do they keep the automatic transmission fluid?
No, it's just a totally different chamber.
But
I mean, the actual is sealed on that one. It's sealed. The pinion gear comes out of a seal. See what I'm saying? I mean, the pinion gears, the shafts go through a seal on that one, and it actually is. But there's none of this oil is ever supposed to make it in there, and none of this oil is ever supposed to make it.
What happens if it does?
Well, it's typically this one right here. This kind of gear can operate with automatic transmission fluid without that big of a deal. The ones that like on the old Volkswagen Quantums and stuff, if it started mixing transmission oil with the gear grease on those high point gears, which is the gears like in the regular differential on the front wheel drive part, it would sharpen those teeth off like a razor. I mean, it is really net. Doggone, you got to put that stuff together. All right, there's your differential gears. The spider gears we were talking about earlier is right there. Input cluster shaft, and there's your C right there. See that? Now there's your cluster shaft. Notice they call that a cluster shaft.
Why?
Well, you remember your cluster gear on your other transmission was the one that was running parallel to your main shaft? On this one, look at how many shafts you got. 1, 2, 3. You got 3 shafts on it. They have to do it that way. See, you got this other shaft over here. Main shaft assembly is D. See all that stuff there? So you notice on the front wheel drive transmission, the main shaft is the one that's hooked to the clutch disc. Got it? Remember that? On this particular one here, the main shaft is the one that is driven by the clutch. So the clutch disc on this one drives the cluster gear, and the cluster gear drives the main shaft. And the main shaft, on the end of the main shaft, is where your pinion gear is. It drives your differential gear. Now, you might notice that something else is missing. That does not have a pilot part of that shaft sticking out. In other words, it doesn't go into a pilot bearing in the back of the crankshaft like the other ones do. You notice that? Doesn't do that.
It makes a bad
I don't know.
right there.
Some of these do. Some of them do, but most of them don't.
Why?
They just don't need it because it's shorter. It doesn't. You see, it doesn't go as far. But sometimes they will have. Now, you might also notice that it's got these tapered bearings here, tapered roller bearings on each end, and so you have to be careful when you're setting that up so the end plate is right, the preload's right, and all that. I mean, that's part of the deal on there.
You gotta have preload in the transmission?
Yeah, right here because of the fact that it's got those kind of, it's not quite as critical as it is in the rear end, but it still has to be done. So you got main shaft's got 4 forward gears, reverse gears, and first, second, third, fourth synchronizers. It's got a drive pinion for input and differential, all gears except fifth. All right. Fifth gear shaft assembly is E. See it up there? There's your fifth gear shaft assembly. It's way up there. And look at, and then K down here is your synchronizers. That's what they call these. Actually, when we think of synchronizers, we point to the little blocker rings, the little brass ones. That's what we call synchronizers. The sticklers for transmission stuff call these parts right here, the part that the shift fork goes into, they call that a synchronizer. You know, because it's all a part of the big picture. The reverse idler gear is F. I'm sorry, I moved it, thought somebody's out there. The reverse idler gear is F. It engages the reverse gear on the input clutcher shaft. See F right there? Where's F? I'm missing it. I'm sorry. Right there it is. It's back there. You might notice that this shaft right here actually looks like it's geared to that one, but it's not touching it. These two gears miss each other. When that reverse idler gear cogs together with those, it adds another gear, and that gives you your backwards. And then you get your final drive ring gear, your differential case, your side and pinion gear, blah, blah, blah. That's old news there. All right, we're going on down. All right, now we're not going to read all of that. You know what I'm saying? This is kind of silly to put that much text on that. And that picture right there is not really all that clear at this point. But the input shaft provides selection of the desired shift roll, you know, so on and so forth. Let me go over here and get to the picture right here. If I can get it to zoom in a little better than that, we might get a better picture of that, and we can look at it closer. You can kind of recognize what we got over here on the bench, right? See what we got there? See them tapered roller bearings in there? There's an interlock sleeve. Now, you do know that the shift rail on all these transmissions and transaxles is set up so that there's balls and interlocks so that you can't put it in 2 gears at once while you're driving down the road, while you're at any time, because if you do, it locks the transmission out and it won't go nowhere. Let's look at our power flow. This is what's easy to see. In neutral, nothing is in gear. You got power coming in from your clutch, it goes all the way through here, and everything's just kind of whirling up a storm, but nothing's being transmitted down here. See that? That transmissional torque right there. Okay, so engine drives input cluster gear shaft. Well, let's see if I can zoom in a shade more on that so we get a better shot of that. All right, turns the cluster. The synchronizer sleeves are centered. Now we saw that when we were doing this on the table earlier, right? The mating gears on the main shaft and 5th gear shaft aren't engaged to any shaft and they freewheel. All right, so now we're going to go down. That's power flow in neutral. All right, now we're going to go to 1st gear. This is where it gets pretty interesting. Engine's driving the cluster gear shaft. The 1st and 2nd gear synchronizer is engaged to first gear, and the synchronizer has engaged the main shaft. My laser died. Okay, there you go. Well, it got loose on the back. Is what happened. I had to fix my laser. Okay, you got to see where it's going. Look, this shaft is moved forward, and it has locked this gear to that shaft. So now this gear is driving that gear is locked to that shaft. Now you remember, these little suckers right here are a part of that shaft right there. You got that? And unless these are locked to the gear is just whirling free on that shaft. So when you move that one forward, that's going to give you your 1st gear. See that? This is driving that, that's driving this is driving the pinion, that's driving and your CV axles are going out that way, right? Everybody got that? You understand it? Power flow 1st gear. You better be able to do this for me on that one over there. I don't have the 5th gear shaft on that one over there, but I've got all the rest of the gears. But you could go through. It got gone. I mean, it wasn't so that it, couldn't. Actually, it was gone when I got that. So this guy at the Ford place gave me that transmission, the 5th gear shaft. I don't know if he pirated it out of there or whatever, but he gave it to me just like you see it right there, and that's how I brought it up here. Here's 2nd gear. This is pretty cool. And 2nd gear is driving it. Now, what happened here is this little synchronizer sleeve moved back, and it locked into that one right there. See that? See that synchronizer? It clicked back over there, and it's got the driving that gear. Remember, all this gears, this is all solid, this cluster gear. You see what I'm talking about? All right, it's driving that, and now that's driving, now that this gear is locked into that shaft, it's driving that pinion gear, and that's going out to your CV axle. And that's it right there. All right, now we're going to go down to 3rd gear. Let's look at 3rd gear. This is pretty interesting stuff if you're a gearhead. All right, drives the cluster shaft, see it going this way. Now, see this one? That's moving forward. That's got this gear locked to that. See, now this gear is now, because that is splined onto this permanently. You lock that in. This one here is actually transmitting the torque to this. This is actually transmitting torque, and if I do this exactly right, this transmits torque to that. That transmits torque down the center to this. And then that goes out that way. So you can see that? And obviously when we come back, if I did this the right way, I'd make an animation of it, right? There's 4th gear. And that looks pretty good. 4th gear is going all the way through to the back. And the back of the cluster gear is driving that one. And then that's coming over here. And so see how each one of these gears going back is bigger? You understand what I'm saying? This one here has got heavier teeth on it. That's 1st. All right, and this one here is 2nd, 3rd, and 4th. You can see those. Remember how we were talking about before on the rear wheel drive transmissions? 4th gear was a straight lockup. This one is not like that, but what you do have is you've got this gear is the same size as that one. You see what I'm going? That's an actually 1-to-1 ratio on that.
Okay, so it's basically the same thing.
Yeah, it's 1-to-1, but it's not a straight lockup.
Right.
You see, it's the same. Yeah, exactly. That's what Lawrence said. Same size gear. Good deal. Now look at 5th gear. Wow, we're looking at this a totally different way now. Isn't that something? Now what's going on here? This view is inverted with a differential at the top to show the gear shaft, pinion, and final drive gear Isn't that crazy? Look at what they done to us. Wait a minute. I thought this one here was a.
Yeah, it was.
Wait a minute. What's wrong with this picture? I mean, I didn't draw this picture. That's the way to do it. You know, what do you think about that? You're looking at the bottom. Yeah, you're looking at the bottom. Let's go back up. See that?
Yeah.
It looks like they just moved everything all over the place, isn't it?
They did.
Why in the world would they do that? But I mean, like I say, I didn't draw the picture.
I
That's
think
just
you need
crazy.
to write them an email.
Yeah, that's something. Well, this is an old book. I wouldn't be able to do this like this if it was, I mean, actually record it for my YouTube thing if it was, the copyright's pretty much expired on this. This book's got to be 25 years old. But,
That explains why they messed up.
yeah, well, not really. 25 years ago, they were pretty smart. But somebody fouled up on this deal. Engine drives the input cluster gear shaft. Fifth synchronizer is engaged the fifth gear. Synchronizer hubs engage the fifth gear drive shaft. Fourth gear on the input cluster gear drives fifth gear on the fifth gear drive shaft. Fifth gear drive shaft drive differential.
So how does it work?
Well, this is a crazy thing to me, and I always love getting crossed up on this, but this is the way the power flow works, however they've drawn it. Now, how in the Sam Hill, they used to have this, hooked up down here, and now they've moved it up there. I may be stupid, but it seems to me like somebody fouled up when they drew that. You know what I mean? If anybody can figure that out and tell me where I'm wrong about that. But when you start looking at these diagrams, that's when you get in trouble, And then there's
Down the back, look at that.
see that? Now, why did Sam really do it? Now, look, see, they tried to explain this.
I don't understand it because how's it going to go through there?
To show the fifth gear shaft pinion and final drive gear engagement.
Well,
Actually, what they're trying to act like is that they're always engaged, you just can't see it on this side.
Whatever.
You know what I mean?
Like the fifth gear shaft is under.
Yeah, like the fifth gear shaft is actually in a different spot.
Oh, okay.
And because of their fact that they're drawing it, it's not in the same place. You see what I'm saying? They had to draw it so that it wouldn't get tangled up. And what they're obviously trying to say is, these are always engaged all the time in the real world. But on their picture, they couldn't draw it that way, or if they did, they wouldn't be able to show you neat little arrows going through that. I think I could have probably figured out a better way to do that, but it gets smacked around every time I go through this darn thing. All right, and there's your reverse. And reverse, actually, that's what I was talking about here. The reverse, whenever that reverse idler clicks over and hooks that one to this one. So you actually add the third gear to the mix, and that's what gives you your reverse. So if you've got an odd number of gears, that's the way it's going to be. So which direction does the engine turn?
Same way.
What does that mean?
Which direction does the engine turn?
Yeah. Look at that transaxle and tell me which way the engine turns.
Like this.
Huh?
Clockwise.
Count.
But we're in reverse now, right?
Right.
The engine is always going to turn the same way the wheels roll in forward. No matter which way the engine is in the car, it's always going to turn the same way the wheels roll, else they'd have to put four reverse gears. See what I'm saying? I mean, that's got to be designed from the ground up. All right, now look at your problem diagnosis. Road test, verify correct fluid level, transaxle leak, shifting problems, erratic noises. If you got erratic noises, you got to go decide if it's noisy in neutral or noisy in forward gears, so on and so forth. If they clash when they shift, or if it shifts hard, if it walks out of gear, like boom. My dad had worked at a Volkswagen shop for years and years and years and years and years and years, and he did transmissions and everything. And he had an old Bug that he drove that it would jump out of fourth gear. And he never, you don't get around to fixing your own darn car, you're working everybody else, because that's where the money's at. So whenever you're working on it, money's going out, he needed money coming in. Yeah. So he took a stiff rod and he drilled a little place in the gear selector. And when he put it in fourth gear, he'd prop that rod between the gear shift lever knob and the dashboard. And it would hold it in there. He didn't have to keep his hand on it. I don't know what my dad thinks, but it wasn't that he couldn't fix it, he didn't want to take the time to do it, One time there was a couple of jack stands and a 17mm wrench and a screwdriver, and you can have a Volkswagen Bug motor on the ground in 20 minutes if you know how to do it. And they just stab it right back in. You got to take a sheet metal off around the back of the motor and all that, but it's real easy and quick. And he used to make good money working on Bugs. For 30 years he did that.
You said that reverse control gear
Yeah.
would only be if it was an odd number of gears. What if you have a 6-speed front wheel drive?
Yeah. Well, you're still going to have the same deal.
Well,
You're
you said
going to
it'd be
you're going to have an
opposite.
odd number of gears. I'm talking about when you got two shafts and you add the third gear. That's what gives you the other. Because you're basically, you got to look at how everything is rolling together. If it's going this way and you add a third gear, it's going to go backwards. You know, you've got to do the number of gears and all that. All right. Okay, let's walk through this test right quick now while we're here. And then we'll look at these grades up here. Technician A says transaxle leak can be caused by using the wrong type of lubricant. Technician B says fluid on the lower case surfaces may or may not be leaking from the transaxle. Who's right about that? Both of those guys are right. Technician A says each bearing that will be reused should be kept with its original race.
True.
Technician B says roller bearing shims should be installed under the bearing cones.
Not about that, but I know he's right.
Well, what's the cone? What's the cone and what's the cup?
The cup's the race, isn't it?
Yeah, the cup is the race. You know, the part of the bearing that looks like this, it's got your rollers in it. You know, that's the cone. And the cup, you know, a cross section of the cup is like this right here. If you look at it, in other words, if you just look at it, it's drawn like this. But up in here, you got that cone. This is the cup, that's the cone. If anybody's talking about cup and cone, you know, a bearing basically looks like this right here. And all that. Don't ever hold one of these bearings in your hand, by the way, and spin it with air. That's fun and it sounds cool. Woo! But if that comes apart, it can cut your finger off and rollers go everywhere and it puts out eyeballs and bends people's paint job, scratch the paint and bust the glass and you know, but you can hear some goofy son of a gun in there with a wheel bearing he's cleaning or something, spinning it with air. Ooh, you know, let's just play Russian roulette here. Boom, boom. You know, that's bad news, man. Don't ever do that. I got to caution you against that. I mean, and you'll hear people doing it. You also have people taking a stupid air blower and blowing brake dust off. You know, that's dumb too. See people do that. All right.
Kill everybody in the shop.
Yeah, well, eventually, mesothelioma. All right. The engine drives the main shaft. True or false?
True.
What?
Oh, no.
You're thinking rear wheel drive, buddy. Remember what we just said? The engine drives the cluster gear on this one. That's the way that is.
So what's number 2 then?
Number 2 is actually Tech A. You're not going to put the bearing shims under the bearing cones. See, in order to set your preload, this is on a shaft against a boss. And I should have explained that right here. See that? It's against the boss. And if you're going to set your preload, you got shims that are here.
Just
that
like
you're going to put here, and that's going to make that tighter against that and increase your pressure on those bearings.
Just like a rear end.
Yeah, just like on the rear end. Yeah, you don't typically do. Now, I will tell you one place where you're going to put a shim under the cone is on the pinion gear in a rear differential. Because you do put one under there. That's not for preload. It's for pinion depth. Mm-hmm. So your preload is actually done with the nut, but the pinion depth is set with a shim. See what I'm saying? So you're not going to set the preload on a bearing with a shim under the cone. Everybody got that? Mm-hmm. You got it? You understand the cone and the cup and all that? And you know, usually you can read numbers off those bearings and get just a bearing that's the standard bearing in a lot of cases. All right, engine drives the main shaft. That's false. What's the first step that should be performed when diagnosing any problem? Road test. Remember how I told you my dad would, I'd sit there and people would bring him a transmission in the back of a pickup truck and say, can you fix this because it's making noise? He said, not till you put it back in the car so I can drive the car. He wouldn't touch it if he couldn't test drive it. You know, you could go in there and, you know, claim you were going to fix it and replace every gear in there. In this particular transaxle, what type of bearings are used? Oh, come on, guys. What am I talking about? What do you call these? What am I drawing on the board up here?
Roller bearing.
Tapered roller bearing. Not just roller bearings, tapered roller bearings. Technician A says an improperly installed shifter boot can cause the axle to jump out of gear. What did I say? Did I talk about that earlier? An improperly installed shifter boot can cause it to jump out of gear. Technician B says neutral gear rollover noise in a transaxle indicates problems with the gear train and some of the transaxle components will need replacing. Who's right about that? All right. Actually, no. Neutral gear rollover noise is normal. You're going to have that. Part of the deal, guys. Neutral gear rollover noise is normal. All right. Technician A says the throwout bearing on this transaxle should not be in contact with the clutch release fingers on the transaxle unless the clutch is depressed. Technician B says a faulty throwout bearing on this transaxle will make noise regardless of whether or not the clutch pedal is pressed. On this particular one, the throwout bearing is always going to be against those fingers. Matter of fact, on most of the transmissions you see today, they're like years ago, we didn't want them touching. But we just didn't want them. Why have it touch if it's going to be spinning for no reason? But now, like on these concentric clutches that's got that slave cylinder in there that's built around the...
Like a Ford Ranger?
Yeah, or a Explorer or some of the Ford pickup style. That son of a gun is always against the fingers on the pressure plate. Always is. And so you're going to hear noise like that, you know. All right, so that's going to be a technician B. It actually is going to be in contact with the clutch release fingers, even when the clutch is not depressed. And finally, does this transmission use hypoid gear lubricant?
Hypoid.
What's hypoid gears? Anybody know? Can somebody tell me what hypoid gears are? All right. If you got a ring gear and a pinion, right? Okay, this is your ring. This is your ring gear, right? If you've got a if you've got a gear, a pinion gear that's coming straight in the middle, that is not hypoid. If it's hitting it straight in the middle, that is not a hypoid gear. In other words, if I took and drew a ring gear up here, and I drew a neck so I'm in the center, and I'm coming in right here to drive that son in, that's not hypoid. But if I'm coming in above with my ring gear, I'm coming in there, or if I'm coming in below, which is how most of them work, because it's stronger that way. You got more teeth in there. You do have to set these up just right. But in your old Model A and all them old cars, they would have them going straight in with just a spur gear there. Wasn't as strong as this, and they typically would come apart a lot of time whenever, because you got a lot going on back there. Anyway, if it's going above or below that center line, that's hypoid gear lubricant, and it takes, you know, heavy oil. This one here doesn't have that. What's it got? It's got helical cut gears. You know, just plain old helical cut gears. So you can have, like that transaxle right over there on the bench, it takes automatic transmission fluid. Problem with that is that stuff can leak out of there really, really fast. So now we need to look at this grade business.